Hi class, let us now look at shunt and multipliers. We know a shunt is when you have connected an ammeter in parallel with a resistor. When a resistor is connected across an ammeter or a measuring instrument, we say that is a shunt. Shunt is another word for parallel. When we talk about a multiplier, it means now the load has been connected in series to this particular instrument. So it's always good for you to differentiate between a multiplier and a shunt. So I've said a shunt represents a parallel circuit, a multiplier represents a series circuit. So what happens is, if you are talking about a parallel circuit, remember the properties remain. According to Kirchhoff's current law, if the current you intend to measure is I, then it means upon reaching this junction, the current is going to split into two. There is that current that will be going to the instrument or the ammeter, and there is that current that will divide to the resistor. One thing that will assist us is we know the voltage across the ammeter and the voltage across the load will be the same. And what will happen is we will say the voltage across the ammeter will be IA multiplied by RA. That is the voltage drop across the ammeter. It will be the same as the voltage drop across this particular resistor. This resistor will be taking IS RS. That is the explanation for that. We now want to look at the multiplier circuit. Remember, for multiplier circuit, we know the total voltage in the circuit will be equal to the voltage drop across this plus the voltage drop across this. So basically, you can see for a shunt, we'll be using Kirchhoff's current law because the current is dividing. For a multiplier circuit, we shall be using Kirchhoff's voltage law because we are saying the total voltage is equal to the voltage drop across this plus the voltage across that. So we can now get that equation. We'll say V will be equal to the voltage drop across this. So let us say this is the current which was flowing in that particular circuit. Then we would say the voltage drop across this is I RA plus I RM. So these are the two equations that are very essential whenever you'll be sorting equations of that kind. So we want now to look at an example. If you are given an example of this value, calculate the value of the shunt to be connected in parallel. You can take that example. It says calculate the value of the shunt to be connected in parallel. The shunt to be connected in parallel with the meter to enable it to be used as an ammeter, an ammeter for measuring currents up to 50 amperes. We are supposed to get the value of the shunt to be connected in parallel with the meter to enable it to be used as an ammeter for measuring currents up to 50 amperes. Remember, the circuit remains to be this, but the current we are measuring is 50, so meaning our I becomes 50 amperes. And remember, we have been told in the equation still we have this information that we need to get. The instrument is a moving coil a moving coil gives a full deflection when the current is 40 milliamperes and its resistance is 25 ohms. So we are told a moving coil gives a full scale deflection when the current is 40 milliamperes and its resistance is this. We are supposed to calculate the shunt resistance to be connected in parallel to ensure it is able to read up to 50. So basically what you need to know is for a full scale deflection, this thing measures 40 milliamperes. That is the current it is able to read. So meaning our IA is equals to that. Our IA is equals to that. And then our RA is 25. We have been given that in the equation. So now basically what we need to get is the shunt resistance. We said the equation that is used here is RA is equals to IS RS. So that is very important to be noted. Because we know the current flowing across this, we can be able to get the current flowing across this. So basically another equation that you need to know is I is equals to IA plus IS. That is very important according to Kirchhoff's current law. So meaning you need to convert this one into amperes. So meaning 50 will be equal to, our IA is 0.04. If you divide by 1,000, you will get that, plus IS. So therefore, our IS will be equal to, if you take this one to the other side, you will be able to get 49.96 amperes. If you subtract this one on the other side, you will be able to get that. Once you get your IS as that, we can now be able to apply this formula. Remember what we are looking is for RS. We know our IA is 0.04 multiplied by our RA is 25 should be equal to, we know our IS is 49.96 multiplied by RS. So therefore, this tells you that our RS will be equal to 0.04 times 25 divided by 49.96. So our RS will be equal to, if you divide, you will now be able to get 0.02002 ohms. Or if you like it, you convert it into milli, so that our RS is equals to 20.02 milli ohms. So that is how you calculate for the resistance whenever you want to get the shunt resistance. The shunt resistance will be given by that. If it is a multiplier, of course, you need to use the diagram we had drawn before. So up to now, I want to say we can stop there and thank you.